Will somebody hit the light switch, hit number 2 on the button? Yay. All right. Thank you so much for the lights. Let's, says we want the limit. So let's make sure we're okay with this, feeling comfortable. So this means that I want to approach 0 from the negative direction. So that means I'm approaching here. So what is the y value as I approach that 0 right there? What's the y value? 5. And if I do this one coming this way, for that, what does that y value get to? 5. So friends, do the pink, I think it's pink, and the green, do they get to the exact same location? Do they both get to 5? So the limit exists at 5. If they went to 2 different places, if I came from the left and the right, then that might not be as good for us. All right, so then I want to make sure you feel comfortable with this. H at 3. So what we're going to do is we're going to go to 3, and what I do with the 3 is I'm going to come kind of straight up here until I find a solid dot. I have a solid dot there. So what is that answer, the y component at that answer? Like stirrup, it's still 5. And what if I go on this one? Yo. See, brother. And so if I go here, that's just going straight on up until I get to that point right there. And that point is also 5. Maybe one of these won't be 5. What about this one? H at 2. So I get to right there. What's the y value right there in the orange? 0. Cool. And then we need to approach this from the negative direction. Let's see. Ooh, we'll do rainbow. That's fun. All right. So I'm coming from the negative numbers 2, 3. So I'm coming here. So where is this getting to? What's that? What is that y value right there? 2. And let's change a different one. Ooh, Starry Night. All right, this one, I'm going to approach 3 from this side. So I'm coming up here. And what is the y value right there? 5. So when I come from the left and I come to the right, so this is coming from left or coming from the right, are those the same numbers? Are 2 and 5 the same numbers this week? Phones away, please. Books out. Are these the same numbers? No. So does the limit exist? Nope. D-N-E. Does not exist. Sweet. All right. We feeling comfortable with this kind of stuff? So again, you'll have the test on this on Schoology next Thursday. So a week from today. Today's Thursday, right? I thought about Tuesday, but then I realized I had to move. All right. So let's head down this page, see what we have. So the first one, so let me ask you this. Is 34 plus x a pretty simple equation? I haven't really shown you this yet or not. Is 34 plus x a pretty easy thing? If I had y equals x plus 34, easy to graph. Agree? I don't have any square roots. I don't have any x's in a denominator. So the nice thing is, if this type of thing does take place, this means I could directly plug this in right here. So that's going to be 34 plus negative 35. So that's negative 1. Hello. How are you? So sometimes the limits, I mean, you're always welcome to do it on Schoology all day long. So if I graph that on Schoology, it's going to be pretty simple to, oh, look, there's pictures. Decimals for math. So I can do this way as well. And I welcome you to do it either way. So if I were to graph y equals 34 plus x, and I go find this graph, make it a little darker, and I want to take this out to negative 35. Okay. So this is going to become this y value right here. So it's going to come out to -1. So if I directly plug that one in, I got the -1. Or if I use decimals, again, my friends, I don't care if you use decimals or you directly plug it in, because they don't all directly plug in. So I don't want you to get used to always directly plugging in. I want you to get used to saying decimals is a really good place to get back to. Okay. When I get to this next problem, if you directly plug it in right now, you're going to get 0 in the denominator. Okay. That 0 in the denominator is going to create a hole. And we want to do the limit as x approaches 3 from both the left and from the right. So let's take a look at here. Just jump on our, I didn't mean to do that. They told us they're getting rid of Firefox from our stuff. Like, okay, that doesn't help me. So y equals x squared minus 9 over x minus 3. And go home. So it's going to be a straight line, and we wanted to see what's happening at 3. So right here. So, friends, what happened at 3? It's undefined. Agree? I'm trying to get it to stay there, but it won't stay there. So everyone agree that undefined? So if you follow my arrow up, I get there. If I follow my arrow down, I get there. So what is that where it is exactly undefined? What does that look like on your graph? And the answer is going to be 6, but I want to show you another way of taking a look at this as well. So you can factor this. X squared minus 9 factors to x plus 3, x minus 3, over x minus 3. And then the nice thing is these x minus 3's cancel. So then we just wind up getting x plus 3. I can directly plug this in here, so I'll get 3 plus 3, which is also 6. But we could show it either way. Okay, so again, sometimes it'll work out really nicely if it factors. Again, if you get to Desmos, you're looking for the undefined on some of these, not all of them. And then let's take a look at this one here. So that's kind of a, I mean, I guess I could factor it, but I don't know if I want to. I'm going to the wrong location again. Remind me to go to Chrome. So we're going to go x squared minus 8x plus 7 over x squared minus 6x minus 7. And we want to know what is taking place as our limit gets to 7. Okay. So as I go to 7, and this is from both directions, so 7 is here. Okay. Come back a little bit. Come back. Okay. So what that means at 7, exactly at 7, it's undefined. which means that there's a hole there, which means if I would have factored out the top and the bottom, one of the binomials would have factored out. So can I come from the left and to the right and get exactly at that point? And the answer is yes. But now it becomes a little tricky because it's not really 1, it's something else. So let's see how maybe we could focus on doing this problem. Is someone doing Duolingo? That chime sounds like Duolingo. So if we factor this, what two numbers multiply to give me 7, add to give me 8? And that's going to be -7 and -1. And then on this bottom one, what two numbers multiply to give me -7, add to give me -6? That's x minus 7 and x plus 1. And then the reason there was a hole there, an undefined term, is those canceled out at 7. Okay? Which means if I took the x minus 1 and the x plus 1, once I factored stuff out, and I directly plug 7 in, this is going to give me 7 minus 8. No. Stir up 7 minus 1 and 7 plus 1. So that comes out to 6/8, which is 3/4. Okay. And you might be able to get that on Desmos, but it's going to be tough to get it on Desmos because we can't really see it at the 7. You know, we could sit there and try and hover around it saying, well, it's like 0.75, 0.75. So if you hover around the hole, it'll kind of tell you that you're right about 0.75 at that exact point. Does that make sense? See, my y value is 0.74906. Undefined, 0.75062. So that exact point where it's undefined is at 0.75 or 3/4 or something like that. Okay? All right. Everyone doing well? Am I going too fast? Have I taught the class enough that you'll be able to handle it on your test? Okay. How do I want to do this one? I think we can do it. Okay. This is what they call a piecewise function, meaning you have two different graphs that you're representing. One of them are values that are less than 3, and one are values that are greater than 3, but also equal to 3. So on this particular problem, you're going to utilize this one down here for 3. And so what you can do here is you can just directly plug it in. So you're going to get 3 squared minus 3, which is 9 minus 3. So this answer would just come out to 6. The reason I don't use the top one is we have the equal sign on the inequality on number 5. Okay. Sweet. Let's do those. All right. And last one we'll go over for today. So I have shown you some ways where it's like, wait a minute, he was factoring. So this top factor is the x plus 3, x plus 3. The bottom factor is the x minus 2. I don't have a hole on this one, but I do have an undefined term at 2, because if I plug 2 in, I get a 0 in the denominator. So I don't have a hole here. So this one, the best thing to do on this one is perhaps we don't look at the equation. Perhaps we just jump right to Desmos, see what happens when we're graphing it. So x squared plus 6x plus 9 over x minus 2. And go back to our home. All right. And we're looking at 7. Okay. So we're looking at our x equals 2. Right? X equals. So if I plot this, x equals 2. Okay. The thing to see on this problem is this. The limit was coming from both ways. So as I come from the negative direction, this takes a sharp turn and heads down to negative infinity. So if it's bound by the left, we're okay saying negative infinity. If I come down this way, it does this curve and goes straight up, which goes to positive infinity. So being exactly at 2, depending on which way I came, it either goes to positive infinity or negative infinity. Is positive infinity the exact same thing as negative infinity? I mean, they're both enormously big, but one's in one direction, one's in another. So does the limit exist on this problem? What do you think? B in the graph does this, and this is exactly at 2. This is going to positive infinity, and this is going to negative infinity. Does that limit exist? No. So it does not exist. They went to 2 different locations. They didn't give us a direction on this, so that's kind of what we're working at. Okay? Questions for me? All right. I'm trying to think. Okay, so yeah, that'll work. That'll work. All right. So I feel that you guys can take the rest of the period and get all of these done. Get all of them done. I want to check this off at the end of the period. See how you do. Okay, so get 7 through 11 all done. Work together, figure it out, and we'll go with it.